Just a really quick introduction. I'll flash up the screen here in a second. Federal Safety Officer Adam Taunton started with the office in 2007, I believe, and have been with the scheme ever since. So what we wanted to discuss today was the approach taken by FSOs and by the OFSC at Audit for electrical. Shape are going to come in after us and have a bit of a discussion about the more practical issues and things that they've experienced on site and that they do well. We are essentially going to go through a bit of an introduction for myself. Again, electrician was the background for me, and went into a safety based after a serious incident and never really changed career paths after that. What we're going to go through is compliance documentation. So what we use and what we refer to when we conduct audits. We're going to go through each of the criteria from H12.1 through to 12.7. We're going to have a look at some snapshot data with a few graphs and things like that will just give us a bit of an idea as to the areas that we are going through some issues. And then obviously we'll finish off with some supervision of apprentices, young workers and trades assistants, i.e. non-qualified electrical workers that typically do work in the electrical industry, but that aren't necessarily qualified to do certain tasks. What do we use when we go through audits? First step, obviously, is that we talk to the state, or we look to the state and territory regulations. There are some states that have Electrical Safety Act and safety regulations that are applicable to what we look at. There are other states that don't, and they refer back to Australian standards and codes of practice, which we use. So typically we have code of practice, obviously, for managing electrical risks. We have Australian standard, which more prominently based on 3012 is probably the key standard that we go to. 3760 is a support standard, which talks about testing and tagging and things like that. But again, it's actually superseded by 3012 in a number of areas. And then obviously AS 3000, which is the installation guidelines. Now that becomes more of a technical document, which is to what the installation needs to be installed against. We typically look for the certification to that when we're getting the regulatory. And we then go to obviously local obligations. Now there's a number of things that come into play. That includes the install, any licensing and testing requirements in the state or territory that we're in, including the locality. So sometimes that may be different. If I use as an example Snowy 2.0 or projects like that, they might have additional requirements that get imposed, and we look to how the company works alongside that. We look to how we lodge the evidence of testing with the local authorities, and that can be, as I said before, can be a number of different levels, state-based or local-based. And then we look for the industry requirements or state and territory-based requirements for certain things, such as mining, when we talk about plant isolation, confined spaces and electrical installations within confined spaces, substations and additional works when we're in and around live substations. And then there's obviously the asset owner, which we talked about. If we move on to the criteria, we start with H12.1, which is the general criteria around the risks associated with electrical installations and electrical equipment, identified, assessed and controlled in accordance with the hierarchy of control. So obviously here we're looking about the HIRAC process. We're looking about project risk assessments, SWIMs, various electrical assessments that get completed when we start to work in and near and around electricity. And we're looking for an application of a good level of hierarchy of control. So rather than just running straight to we're wearing arc-rated clothing or we're doing things around electrical spaces, we would prefer to look at how we either reduce or eliminate the risk. In other words, we separate construction wiring, we have mass isolation instead of specific isolation of one circuit. In other words, turn it all off and then we know that it's all de-energized. We've seen some really cool things in the industry in terms of extra low voltage, which again reduces the risks in terms of the actual potential when it comes around. And then obviously the one that we primarily want to highlight as well is the prohibition of working on energized electrical equipment. So there are certain exceptions to that, and we'll go through those as we go through the program. One thing that we don't want to do is to get too far into those defined exceptions because they are different in each state or territory, depending on the regulations in that state. If we go to some of the things that we see and that we would potentially accept as evidence, our initial plans of the electrical circuits, details that have been provided by either the owner of the building, of the asset, of the electrical known services and things like that. We've all seen Before You Dig. It's a similar approach to planning. We see some make safe based documentation, and you'll see some of that with the shape guys with their electrical survey. And then we see things like physical barriers, exclusion zones, and prohibition of entry into certain spaces, such as ceiling grids and things like that, when we actually know that there's energized equipment in there. These are a blend, and this is not all encompassing. H12.1 is our broad look at electrical to give us a bit of an understanding as to how the company has assessed the electrical risks on the project and then determine what those control measures need to be. That includes where we get to a point of electrical installations that aren't necessarily conforming when we go in. Now, if we see usually two situations, one is we'll install temporary power for a construction site, which is installed in accordance with 3012. The other situation is where we utilise some of the conditions within the premises when we're doing fit out or refurbishments and things like that, and they'll bring it up to standard. Now, it is a case where we do need to bring all of those up to standard in order to use them for construction practices. So we need to then think about, if we've got a really old installation, how do we get that to a point where it's compliant to be used as a construction wiring system. 12.2 then goes into our lockout tag out. So isolation, de-energization, lockout tag out, and then re-energization at the end of that process. So that circular loop is quite often missed in terms of the steps that are required to identify the necessary circuits, to turn them off, to make sure that the electricians have physically prevented those circuits from being re-energized. So it's not just a case of, switching it off and putting a little bit of tape over the circuit breaker and things like that. They physically have to tag these out, put an isolation tag, and put a lockout on it to prevent that from being turned back on again. So the idea being, we then would seek to how the principal contractor assures that. So it's not a case of the contractor having to actually define that process in all terms. What they have to have is a system that ensures that you obtain that or develop it yourself, so that we know that when we walk out onto site, we have a rock solid program of isolation, de-energization, and then lockout, so that then we don't have any potential. We wanted to highlight one of the things that we are seeing more and more of in the current era of generation of electricity is where programmable logic controllers, so building management systems, battery backup systems such as UPS and the like, generators, etc. And solar systems can provide a feedback loop when something is isolated and switched off. So we've had a number of incidences where people have turned it off, we've confirmed, but after a set period, then the other system kicks in and we end up with a voltage that gets generated back into the system, which then becomes a potential danger. What we look for is, how do we plan for understanding the systems that are in play at the site, what the isolation and de-energization requirements are going to be, how we're going to prevent them from being re-energized, and that making sure that we have no cross connection or even illegal connections which might be providing a power feed into the areas that we're about to work in or on. It also talks about working near energized parts. So energized parts are obviously parts of the system that have electricity in them, that are energized. In other words, it's live, we call it. We then look to the potential for a person to reach, touch, or strike. Now, again, those definitions is what comes in under the near. We're not talking about in the vicinity where we're a little bit further away. This gets into the near zone where we have a potential for a person to actually touch or disturb the electrical part. So in other words, if I use some examples there, working in a ceiling grid where we know the wiring is or can potentially be live in some areas, typically we look for the controls to manage that process. And again, you'll see some examples of that later. We look to things like civil works where we know that certain conduits have live services in them. They might be installed by the actual construction project, but we understand what those are and how we work around them. And we're looking for defined controls in this space to make sure that when we're working in and around all these parts, including switchboards, transformers, cable trays, etc., where we have certain parts that might be live, that we have an ability to set in place some control measures, which include things like isolation, includes things like, physical barriers at times, sometimes it's labeling, color coding, other various control measures, so that we can manage that working near the energized parts. One of the things that we did want to talk about as well is the re-energization. Planning for the re-energization is critical in terms of when we are turning circuits back on. We want to know that the process is in a planned state, so that it's not just essentially, we've done all of our tests and we're turning it all on. We want to make sure that the validation of that process is in a controlled fashion so that we know which parts are now turned on, that there's a communication of that these parts are now energized and live and have the potential to be dangerous. And then we go into the other part, which is exclusion zones, until we get to a point where we're confirming that everything's okay and it's safe to move forward with other control measures. Page 12.3 goes into the system ensures that RCD protection provided on portable generators and all wiring used for construction work. That's the first part of this. The second part is quite simple. In other words, construction wiring clearly marked. AS 3012 talks specifically about the marking of construction wiring, the yellow tape, the spacing, etc. So we would look to that. RCD is a fairly simple approach to looking at electrical safety in terms of we have our milliseconds and our milliamps, and depending on the installation and the type, will determine what RCDs are required. When we go through that, it needs to be on the final subcircuit. So in other words, it's closest to the point of where the operation will be required. In other words, it's usually on each temporary switchboard has its own RCD setup. We then go to having a look at upgrading systems if we don't have it. There are ways and means of using alternative boxes and things like that that give us our RCD protection. But the idea is that we have that protection, that it's tested. And when we say tested, they go into the next criteria. When we talk about RCDs on generators, there are several different ways of installing an RCD onto a generator. The obligation on principal contractors when we start to run through that is not necessarily to understand what that means in terms of star or delta or anything like that, but it's more about how that is going to operate. If it is provided with an earth stake, that earth stake needs to be in the ground. We need to have a push button test, etc. And we need to make sure that we've validated that the actual RCD system works. The part of which we've just talked about there already is that for every 5 meters having the yellow construction wiring tape. Identification of other wiring that might be energized, that may be not necessarily construction wiring, that may be something else in that space. When we get to the 12.4, it talks about ensuring that testing and tagging of electrical equipment and RCDs is completed in accordance with the legislation, codes of practice and Australian standards. So typically we look to the table in AS 3012 for construction sites, which will talk specifically to the push button testing and the actual operation testing for RCDs. And it will also talk to the actual electrical equipment that we have on construction sites. It will talk about the frequency, the type of installation, etc. We follow that very strictly, and it will talk about test and tag and plug-in equipment, switchboards, the registers that we require or the information that we require to prove that the tests have been completed, and the test results. One of the things that quite often comes up is recording the milliseconds, milliamps and things like that for the test results when we're testing RCDs. So for most equipment, you'll get a pass or fail because the equipment that we use nowadays, including PATS testers and whatever else we plug it into, will give us a pass or fail. With an RCD, we actually get a recordable number, which needs to be put down, and we'll go through that in another slide, which will talk about the specifics of testing. When we do the tests, they need to be completed by a qualified or trained person. So a qualified electrician is accepted, but there are some conditions where we can go off and do test and tag training. Again, we look for an RTO approved test and tag equivalent that would demonstrate what we are looking for. And again, when we go back to it, we look at the system ensures, which would mean that the principal contractor has to have a process in place to make sure that this is the case. So rather than just accepting records as being okay, we need to then confirm that those tests are completed by a competent and qualified trained person. We then also go into calibrated devices. Now, one of the things that we do highlight in the industry, RCD testers are great when they come out of the box. About 12 months later, usually 12 months, they're required to be calibrated. Again, something that takes such a very close measurement needs to be calibrated to make sure that it's still working. Because again, if we come and test it against another machine and it's not calibrated, then we end up with an RCD that's potentially out of balance and doesn't operate quickly enough and then exposes potential persons to risk. 12.5 goes into ensuring that electrical systems installed for use are inspected and certified correctly, which is where we talked about previously. It's the testing, certification and the regulatory notification that we're required to do. We go into typically there's 3012, 3760 have some details in there. There's some other standards, but again, what we look to is how do you confirm that we have the right testing results? In other words, do we have a lodgement of a certificate with the regulator? And some of those include Notification of electrical work is in Sydney and New South Wales, I believe. Certificate of Electrical Safety in the ACT, and a few other terminologies that get used. Again, we look for that lodgement. One trick with that is a lot of those don't require the actual test results to be recorded. They are a submission to the government to say that we have a compliant system, but don't necessarily go into the actual test results. The test results are required as per 3.9 of 3012, required to be written down. So we have a number of numbers which get put down, including continuity, resistance. There's a number in there of fault loop impedance where it's required, and a few other numbers that should be written down into the testing results somewhere. Whether that's in the notification to the regulator or in a separate document, we're not fussed, but we do need to get that assurance that the numbers are being written down by the electricians and provided. As per 3012, it is now incorporated. So in other words, it's referenced by the legislation, which brings it up into a mandatory standard, not a optional. So we look to that as a strict requirement. The last one there is around qualified electricians to sign off on all testing, not apprentices. Quite often we see 3rd and 4th year apprentices doing testing. If the qualified electrician is on site and supervising all of the testing directly, then that's okay. But it is still the electrician who's qualified that has to sign off on the test results before we go submitting anything. 12.6 goes into system ensures that electrical works are undertaken by qualified and licensed persons, which is a good segue. Again, how do we get to that point? Well, we look for the processes around and the systems around the stipulation of the electrical license and contractor's license. Again, just to clarify, the electrical contractor's license is usually for the business, which means that they're registered in the state or territory as an electrical contractor. It's again a different requirement than the electrical license for the individual worker. So we look at both of those. We look at induction processes, procurement processes. Some of these are online, some of those are face-to-face. There are other training needs and programs which go through to that. But essentially, we're looking for how does the principal contractor confirm that the people that are doing the electrical works are suitably qualified and licensed. And again, that will tie into the last slide, which will then go into supervision of apprentices, TAs, and other people doing the works. We look to the actual electrical contractor's license, the actual electrical license for the individual workers. So again, when we audit this, we'll take some names down from workers that we've seen out on site, and we'll verify those back into the system to make sure that the electrical license has been cited, obtained, quoted, recorded in some way, shape or form to make sure that we have details of the individual to make sure that they are a licensed electrician. What we do see as well in this process is there's seems to be a bit of a lack in the industry of they talk to specifically about having an electrician. There's not a lot of discussion around apprentices, trades assistants, and the processes to manage those people in the industry, so that when we get to the point of we have direct or indirect supervision, we have one electrician to a few apprentices and things like that, how that is to actually play out, which exposes those people that aren't necessarily electricians to potential risks. So we look to that as well. So 12.7 is the last one, which goes into emergency procedures and how they're established specific to the scope of works. Electrical procedures that we look for, or electrical emergency-based procedures that we look for, are really dependent on the environment that you're in. Explosive and flammable atmospheres obviously is a lot more substantial to a construction site, which might have, for example, electrical contact or electrical fire in a sense. So we look for how that is actually aligned to the type and nature of the project. And again, that comes back to the assessment for electrical requirements and emergency preparedness requirements. We look for things like electrical isolation points and identification of those, so that potentially in an instance where the electrician is not necessarily available, that a main switch or something like that is identified, usually on some sort of plans, so that we can turn it off. As a normal person with no electrical experience can go and basically flick a switch, enacting the emergency requirements. That's not mandatory. And again, there are a number of ways in which companies can manage this in terms of planning. And that's how we look at it from a perspective of, we look to what the company defines and then we audit against that. Now, low voltage rescue is one that keeps coming up, and we see low voltage rescue kits and things like that being purchased and put around sites. LV rescue kit is designed to extract a person who is currently already being energized or is under suspicion of being energized. You need to have specific training in LV rescue, and that kit also needs to be suitably tested and validated every set period. So they have a testing frequency. So it's not just a case of, oh, we buy an LV rescue kit and we plonk it in the corner because the guy's working in a switchboard. It is a case where if that is a potential, it needs to come up, and there's a lot more planning that goes with that, including the training, the re-inspection, certification, confirmation, etc. of the LV rescue kits. In some areas, it is mandatory in terms of, say, switchboards at certain locations and things like that where there are live parts. But again, we then go into, okay, do we have a number of people in that room so that if one person does become energized, that the other people can conduct the rescue? So it is really a point of making sure that it's not just, okay, we put down LV rescue kits. There's a whole nother space that goes into that where we then expect that the companies take it to make sure that the full planning is completed as required. Corrective actions, so 34%, 31.9% for 12.2, 30% for 12.5, 27.5 for 12.3, 21, so getting down to the lower numbers for H12.7, which is emergency procedures, then into the last one, 12.6, which is a bit of a concern. It's gone from 9.9%. In other words, it's doubled and a bit in a couple of years. Now, that's a work undertaken by qualified and licensed persons. So that'll come probably because of a heightened awareness within the OFSC's FSOs as well, that we have a number of workers that are doing works in the industry that aren't qualified or licensed or suitably managed in terms of trades assistants, apprentices, etc. 1 electrician to 10 apprentices is not satisfactory, and we would then say that the works aren't being undertaken by suitably qualified licensed persons. It's of a concern that we need to have a look at, and we'll talk to that in the last slide. There's your visual snapshot of that. So in other words, 12.5 being not so great. That's the worst one, which is around the inspected, correctly certified, where we find the majority of that is a failure to actually notify the regulatory agency in the state when we install construction wiring. So when we install temp boards, when we install site sheds and all those sorts of things, there's a certain point once we test and commission that we're required to submit. Now, we can submit certain number of temp boards in bulk to them, and that's accepted depending on the government agency in each state. But it is a case where when we get to site, we're going to look for the electrical installations that are there and the actual inspections that come with that and the records. In the last 3 years, we've had 75 electrical incidents reported to the OFSC. We've had 25% of those have resulted in a longer issue in terms of an LTI. 8% have resulted in MTIs, and 48 or 64% resulted in dangerous occurrence. So when we get to an electrical related incident, it's very important to understand the detail of investigations that we would like to see as a result of that. The difference between, as an example, when an RCD trips on overcurrent versus an actual RCD, they go into 2 different positions. One's in the fully closed or fully open, position. It'll trip to the bottom, and the other one will trip to the middle, which means that it's shown RCD trip. So we need to understand before we go, doing too much work in that space of what was the source and the reason for the trip. We then need to go into talking to how do we get to that stage. A lot of experience that we've had is that it's a bit of a lack of planning in terms of what was energized versus what wasn't, and a lack of communication. So that will be, again, coming back to those permit processes, the isolation, lockout, tag out processes, and the communication processes that we talked about a bit earlier. When we get to the last slide for me, we talk about supervision of electrical apprentices. Typical requirements that we see is a 1-to-1 for first and second years, being a younger apprentice, less experienced, etc. And then we go to a 3-to-1 for third and fourth year. In other words, 3 apprentices potentially to 1 electrician. When we start to mix and combine those in terms of we've got 1 third year and 2 first years, then we start to look to the actual NECA guidelines, which is an actual National Electrical Contractors Association, and then the state and territory requirements, which there are quite a number of states which actually provide supervision guidelines in that space. So we would look to that in terms of who's qualified versus who's an apprentice versus trades assistant, etc. And then we look to also the scope of works that they're undertaking in terms of if it's for a cable tray installation that's not yet part of the system and it hasn't been connected up to the original part at the very beginning, which means it doesn't require an earth or anything yet, then those don't lead out to being part of the electrical installation at that point in time. So again, there's different rules around that. But as soon as it becomes part of the electrical installation, then we start to look to that electrical qualification. When we get to that last one, it's probably just a refresher or a reminder on what we said before. Apprentices are not permitted at any stage until they're qualified to sign off or submit testing and commissioning results or records. And that includes all of the above. It includes the RCD testing and tagging. It includes any testing and commissioning whatsoever.